Okay, so today we're going to do a few different things. We're going to start by making a notes page. And so you can see I've taken my paper and I'm kind of zoomed out here, but I wanted you to see I've turned the page sideways. Remember when we made notes pages in the past that are going to summarize everything that we've been learning really to this point? We turn our pages sideways, okay? And the next thing I'm going to do real quick is I'm just going to create some columns. I'm going to make 3 columns because I want to go over here to this third column. Let me go, let's see, let me get a break here to the next column. Wait a minute. Insert a break to the next column, and then from there insert a break to my next column. So over here on the right and up near the top, I'm going to put my name, Mr. T. I'm going to make everything a bit bigger for you so you can definitely see it here. Okay, and then in the center column, okay, right in the middle, in the very center of that middle column, we're going to have statistics. Oh, wait a minute. I'm not back in my, there's my center column. All right, so statistics. Actually, you know, I got to get everything to be big here real quick. 18, okay. So let's go back here. And so this is my statistics notes, right? So my notes on statistics, what we've been studying about statistics, that should be right in the center, okay? And then over here we're going to start with definitions. And I'm going to zoom in a little bit, and you're going to see me working down over here. We're going to work through a number of different things that we need to make sure we're really comfortable with for our upcoming tests. So I'm coming over here to work on definitions for a minute. So let's start by thinking about some of the terms that we've been using so far. We have been working on, let's see, we used the mean, and the mean kind of meant average. So write average over here, okay? And so let's kind of explain what that means. That means, you remember like when we had lined every kid up from the tallest to the shortest, and we said that, you know, the average height or the mean height would end up making like everybody make just a flat, make everybody the same height. If we were to find one height and spread it across, everybody would be kind of the same. So the first thing is the symbol for average is an X with a bar over it. Okay, I'm going to see if I think I can draw in here. Let me try, just draw real quick. This won't last, but you're going to draw it, okay? So you're going to make an X like this, and you're going to put a bar over it. And make sure that you know that that's for the mean. You're going to draw that like that, for the mean, X with the bar over it. And that means the average, okay? And now we're going to really quickly write down the formula for that, okay? So the formula for that is going to be to add all the numbers together and divide by the count of numbers. Okay, so to give you an example, if I had these numbers, 2, 4, 5, and 6, if they, my average would be 2 plus 4 plus 5 plus 6 divided by 2, okay, which would equal, so 2 plus 4 is 6, 6 and 5 is 11, 11 and 6 is 17, so it would equal 17 divided by 2, which is equal to, not by 2, why did I say 2? Mr. T, it's definitely not by 2. Sorry, we have to count how many numbers were there in the group. 1, 2, 3, 4. So divided by 4. So 17 divided by 4, and the answer is going to be 4.25. And you can put that in your calculator, and it will help you. You know, you can add them up and divide. That's how you find the mean or the average. Okay, another word that we have not used very much at all, but you definitely need to be familiar with, it's called the mode. And why did that get so big again? I want to make that a little bit smaller. Let's try size 14 here. Okay. So, anyway, so the mode, think of the word most. Oops, most, right? So if I had a group, so this would be, let's just explain it and make sure, for whatever reason, this is going back. It wants to keep going back to that 18, but here we go. So the number that shows up in the group, or the set, we might say, the most. So if I had a set like 1, 2, 3, 3, 3, 4, 2, 4, 1, if that was my set, then 3, I can count, I have 1 is in there twice, 2 is in there twice, 4 is in there twice, but 3 is in there 3 times, so I would say 3 is the mode. Mode, okay? I'm going to go like this. I know how to fix this thing. Oops. Alright, let's just get that. And say, hey, I want all of this to be 14. There we go. Okay, so that is another important word, the mode. The number that shows up the most is the mode. Alright, we're going to hit enter again. Get another bullet here going. And then we have the median. So this one is the middle. We're thinking the middle. Remember we talked about the median of the highway, right? We talk about the median of the highway. We're talking about that green belt that goes right in the middle between the two on the interstate, between the two directions on the interstate, okay? So the median is in the middle. We did median quite a bit, right? When we lined up, people lined up and we canceled from one side and the other until we found the one kid that was left in the middle. In order to find the median, you have to put your data in order, right? So let's take that group that we have above right here. 1, 2, 3, 3, 4, 2, 4, 1, 3. That is not in order, right? First I got to list my 1, then my second 1, then my 2, then my second 2, then my 3, then my 3, then my 3, then my 4, then my 4. So that's now in order. 1, 1, 2, 2, 3, 3, 3, 4, 4. So remember kind of how we said before, you would tell the guys on the outside to go sit down. They're not going to be the median, right? So the 1 and the 4, these guys on the outside are out. Then this 1 and this 4 would be out. Then this 2 and this 3 would be out. Then this 2 and this 3 would be out. And the guy left standing in the middle is 3. So our median is 3. And what I would tell you to do, since you're writing your notes, is I would maybe make little marks like this. This is how I usually used to mark it a little bit. I'm going to try and see if I can just make this really a little bit finer. But I would put a little dot next to the guys I just told to sit down, right? So if I said, okay, sit down. So he sits down and he sits down, right? And then he sits down and he sits down, right? And then this guy and this guy, right? And then that one and that one. And so here I'm going to circle the median. The median's the one that gets to stay. So that's my median. And just remember that you couldn't do it when it's not in order. It has to be when it's in order. Okay? Now I'm going to also just try to find the median of this group. Okay? This group, I only have 4 numbers in it, but I'm going to do the same thing. Thankfully, it's already in order, right? 2, 4, 5, 6. That's the order that it goes in. So I'm going to come over here. I'm going to mark it 2 and 6. Those guys would go sit down. And then I have 2 numbers here. I'm going to underline them together, right? So to find the median when I have 2 numbers is I take those 2 numbers, 4, right, plus the number 5, right, 5. Whatever I get when I add them together, I divide it by 2. So in other words, I'm finding the average, right? The average of just these 2 numbers. And that's going to give me 4.5. So my average is 4.5. Now, that's my average of these two numbers. So my median is right in between those two numbers. So for this set, even though my average was 4 1/4, that was my average, but the median for this set was 4 1/2. So notice that the mean and the median are not always the same, right? The mean and the median are not always the same. And in this case, the median was bigger than the mean. Okay? All right, some other things that we need to remember over here from our definition. Oops, here we go. Take that back off again. All right, so we have something that we have been calling the right and left hemisphere, right? So the right and left hemisphere. So what is that? So these are the data on the right and left after ordering, so it's got to be put in order, and separating to find the median, right? So once you've divided, you have the left and the right hemisphere, right? Okay, and then next we have something called Q1. Q1. Okay, so Q1. And this is, sometimes can be thought of, the median of the left hemisphere. So basically what we're thinking about here with Q1 is we're thinking about it represents the end of the first quartile. Oops, I did not want that to go over into my new column. So I'm going to shrink all this stuff down a little bit because I need to fit a little bit more on this column here, right? And I can zoom in a little bit more. In fact, let me zoom in a lot more. Okay, so it represents the end of the first quartile. So numbers on the left of Q1 are considered in the first quartile. Okay, then we have, and numbers on the right, numbers on the right are in the second quartile. Okay, then we have another one that we call Q3. Oops. All right, where's my little bullet? There we go. Q3 is the median of the right hemisphere. Right? And what does that represent? It represents the end of the third quartile, or the beginning of the fourth. So numbers on the left are in the third quartile, and numbers on the right are in the fourth quartile. When I say numbers, it's probably not, some math teacher out there is just cringing probably that I'm calling these numbers. I'm trying to use the name like you and I would just use to call it. But some math teacher would say, well, they're not numbers, right? They're data elements. In other words, they're out of my group, right? And here's this whole set of numbers right here. Each one of these numbers right here is what we call an element in my set, right? So here I have a huge set of numbers, right? 3 is a number, and it's there, right? But each of these 3's is its own element, right? It's its own element. And the 4 is an element. Each of those 4's are its own element in the set. There's a separate element, maybe, is the better way to say it. Okay, so the bottom line is that we got to make sure we're pretty good with those terms. Now we also have a couple more real quick. What else did we learn? We learned the min and the max, right? Which are the largest and smallest. Oh, probably large is not a good word. Let's call it greatest and least. Well, we should say least first, right? Because min comes before max. So min is the least, and max is the greatest of the elements in the set, right? The greatest numbers or elements in the set, right? Okay, so that's a lot of terms that we got, and I think we're pretty comfortable with min and max. You guys found those pretty well. And we'll talk in a minute in one of these other columns. We're going to make notes about how we find all those and interpret them and show them, okay? All right, the next thing that we want to do is we want to get into correlation. We talked a lot about correlation, so let's go with correlation. Is when one number, one quantity, we better say, one quantity, so something that we're measuring or counting, right, and another quantity appear to change together. So what are we saying there? What does that mean? I'm trying to fit a lot here. I get that it's a lot. I'm actually going to go up here and change this yet again just to keep trying to fit it inside where I want it to be, and I'll just keep zooming in here, right? Okay. So what does that mean when one quantity and another quantity appear to change together? So what that means is, you know, when we increase one, the other increases as well, or when we increase one, the other decreases as well. But you can see a correlation. So let me put this in here, right? So a correlation can be easily seen in a scatter plot, right? When we have a scatter plot, we can see a correlation. The data elements, so each of the numbers or data in our set, appear to be together in a line, right? So if it looks like the data elements are pretty much lining up in a certain way, then we have correlation, right? And we have positive correlation, right? And appears to go up and to the right, which means if one is increasing, the other is increasing as well. We're going to draw some of this. I'm going to have you make a couple sketches real quick. And negative correlation is appears to go down and to the left. Strong correlation is when most of the data points are very close to the line of best fit. Talk about that in a minute. And weak is when they are not. Okay, so let's do some drawing a little bit here. Okay, you're going to need to draw a little bit here. But basically, when we're getting into correlation, now we are measuring one number here on the left, one number here. So one number on the y-axis up and down. We're counting something like, you know, this is maybe, you know, I don't know, something that we're counting here, the amount of money that you spent. So let's say this is the amount of money that you spent, right? And then this is maybe how much food you're buying, right? The food that you're buying, right? So if we counted how much food you bought over here, every time you kept buying more and more and more and more food, what do you think is going to happen to the amount of money that you're going to spend? So we would plot. You buy some food, and it appears like as you're adding food, oh, this time when you went to the store, you got so many things of food. But you don't always get the exact amount of food or the same ratio of food. It depends on what kind of food you're getting. But in general, when we make a scatter plot, we're going to notice that, hey, the more food you buy, the more money you spend in general. And we would draw what we call a line of best fit. Right? Well, let me try doing that in a red color. Sorry, here we go. Let's go with another color. So the line of best fit would be the line that kind of goes through all of that. And then we use the line of best fit as our predictor, right? So this one right here, this is an example here of a line of best fit, and this is a positive correlation. And the numbers appear to be pretty good in there, so I would maybe call this positive and strong. Okay, positive and strong. Okay, correlation, pretty strong. Okay, sometimes, and I'm going to draw one here in a minute, and it's going to be weak. Okay, I'll make a positive in week 1 over here on this side a little bit. Okay, you make only as many of these as you feel you need to make sure you're kind of clear. If you need to, you make a bunch. But if it was weak, we would have, we would have a general tendency for the data over here over time to be moving up. But there would be some examples where it didn't quite work that way, okay? And when you drew your line of best fit, it does appear to go that way, but this would be positive but weak. I would call this weak, right? Okay, so you might make a little shorthand example to yourself of weak correlation. Now let's make a negative example over here. We'll make negative and strong. Sometimes, you have something like, maybe this is your weight, right? How much you weigh in pounds, and maybe this over here is how much exercise you do, right? So the more exercise you do, and you keep weighing yourself, and as you keep weighing yourself, as you do exercises, you start to notice something is happening to your weight, right? So that would be, here we have a pretty strong correlation that is negative. So this is a negative correlation, and it's pretty strong, right? strong, because you can see all those pounds, they're pretty close to the line. And then you might have, let's go with a negative weak one. Let's get an example of a negative weak one. So we might be measuring something like how, as it gets later in the year, we might have the temperature, right? So we might count the number of days since Halloween, right? So this is days since Halloween over here, and this will be the temperature. And what happens is, as we get further and further into the winter, right, at some point, the temperature is going to get really low. But there are also sometimes, in December, you might wake up and have some warm temperatures, and Halloween itself might have been cold. So it's just because you're at Halloween does not make this highly predictive. I mean, that's starting to look like there's no correlation. And sometimes there is no correlation. But I'm making a weak correlation here, so I'm going to draw a negative but weak. Negative, but I'm going to call that weak. And really for that to be a little more negative, even though I am going weak, I think I should probably, let me see if I can do this real quick. Get a white color and erase some of this stuff here. Let's see if I can make it a little bit bigger, then that'll help me erase. There we go. There you go. So now I have, it's a little weaker. There's maybe a little data that's off a little bit more, but just like not as strong, it's just weak, right? And then you have the example where there's absolutely no correlation, right? So those are some of the examples of some of the stuff we've been learning about correlation. And you can see that we measure correlation we try to find correlations in almost everything. We look at everything we know and try to figure out, are there any correlations, right? As we're looking at, how much sleep a kid gets. And scientists want to know, is it important that you get a lot of sleep? Well, sometimes, you talk to a kid and you talk to a parent and they argue about it. And they argue and argue. I don't need that much sleep. My parents need a lot. So my grandparents sleep forever, I don't need sleep. I'm fine. I'm fine when I get no sleep. I do even better. Well, sometimes we can argue about that forever, but science doesn't like to just resolve things by argument. They like to find data, and then they like to analyze the data. And what we do, and this is a basis for most of the science that you're going to study going forward, is that we try to collect data and try to make a change in one thing to see if it reflects a change in another. And if so, then we can say, aha, these things are related. They appear to be related to each other. And maybe correlated is what the term is that we would use. They're correlated, these two data sets. And then scientists want to find out, actually, does one thing cause another? Could it be that you're getting bad grades because you're staying up too late and not getting enough sleep? Or could it be that the reason you don't get a lot of good sleep is because you have bad grades? could be the other way around. You know, the fact that you have bad grades is keeping you up at night, you know, adding stress in some way, and then you seek to avoid the I don't know, who knows. So, but what we want to definitely see and understand here for sure is that correlation, understanding correlation, is the foundation for really understanding, really getting and understanding our basic science, what we do in science all the time. Okay. All right, we are going to go on into how to use our calculator a little bit. So we're going to use a different column now. Let me take this off here, and I'm going to, that's, you know, for now, that'll do for our definitions for right now anyway. I'm going to zoom back out so we can kind of see how our page is looking, right? We got all these definitions over here. And then over here on this side, I'm going to start to put in, and put an enter in here and kind of do this. I'm going to change this to get this pretty small again. Okay. And on this, I'm going to, well, let me put actually like this, get it a little bit bigger for a second. And I'm going to put using the calculator. Okay. And now we're going to change this part small. You get a little smaller font in here, and I'll zoom in. Okay, and we're going to go in here a whole ton, and I'm going to slide the page over using the calculator. So the first thing that we've been learning how to do is how to enter in lists and spreadsheets. So we're going to put down a little list of steps to do. So start at the home page or home screen. Right? So we start at the home screen by pressing the home button, okay, on the calculator. And then we're going to start a new document, okay? And don't worry about saving any old documents. Why do I say that, by the way? Well, that's somebody else's job. We start a lot of documents. We don't want to save forever a ton of documents. And so if somebody's got one that's really important, like you've started collecting a lot of information, you don't want to lose it, then you want to save your own document. Make sure you save it all the time. Don't rely on somebody else picking up a calculator and seeing your stuff and deciding to save it, okay? So start a document. Don't worry about saving any old documents, okay? And what kind of page are we going to insert? So we're going to insert a data and statistics page. Oops. All right, got Chrome slowed down here for a minute. Let me get a new page or a new bullet point here. Number 3. So we're going to say insert a data and oh no, we don't want data and statistics. What am I saying? A list and spreadsheet. Okay. Insert list and spreadsheet. I'm going to make these line up that way so that you can see it a little better. Okay, so we want to insert list and spreadsheet. And then up at the top, on the top of the list, right? So hold on. So give a name to each list you create, right? And that goes in the, let me put, in the label row. I'm calling it the label row, and that is basically that row that we've talked about that has, looks like it has a little tag for clothes or a label or something on it, like a price tag, little tag or something, okay? So up there in the label, give your list a name. That's going to be important, okay? And then don't put anything into the equals row. Okay, not for now. We're not putting anything in there. And then we, add the data one piece at a time into the list, right? So one element at a time. I probably should say element at a time, right? One element at a time into the list. So now we've got a bunch. I'm making a list right now, an L-I-S-T, and you can do this as a practice. Let's see, I put 45 and 46 and 41, 42, 43, 48, 46, 45, and 43, and 42 and 40. Okay, there we go. I've got, oh, and I'll go 41 again, and that'll give me 12 items in my list. Okay, so now I've got a list, and if I need to, I can save it. So let me put that in to save. Press doc. Now you're going to press doc and file. Okay, and then you're going to hit 5 to save as. So save as and give your file a name. Okay, and then after that, you know, once saved, you can press Control S to save any new changes. That's a shortcut once you've made your save. Okay? Alright, so now what do we want to do? Well, we only have a single list. Okay? We only have a single list. So what we want to do now is we want to take this list and we want to do some calculations with it. Okay? So let's get a, let me get back over here to a good size and say to make stat calculations. Okay, so if I wanted to calculate things, okay, well, how am I going to do that? If I'm going to make stat calculations, how would I do that? Okay, so to make my stat calculations, first thing I would do is I would go press from my list, press menu, alright? And then we would go statistics, and then we would go stat calculations, and then we would go one variable statistics. Okay, one variable statistics. So you want to press all of those buttons, and then when you do, it says, and then it says the number of lists. So let me put this number of lists should be 1. Of course, if you have 10 lists, separate lists, and you want to calculate these things for each list, you could do it this way, but right now we only have one in this example. Okay, and then in the X1 list, go to the right and select the name of your list. So what I mean by that is you press the button towards the right, and you should see the drop down arrow come up, and it'll give you the names of all the lists you've named. So I see list there, and then you can press enter. And then you would go, and then you would press enter. So then what happens is you have all your stat calculations, right? So you want to remember some of the symbols. So now I'm going to take this number off, and I'm going to draw some of these symbols so you can remember what they each are. And you're going to make a drawing of these as well. So here we go, and make sure that my I'm going to be small enough to fit everything in here, but here we go. So you remember this one right here. Okay, that is our mean, right? Mean. Okay, mean, M-E-A-N. Okay. And then we have one that looks like a sideways M a little bit, like this, right? And it has that symbol, and then I think it has an X. And that symbol is a Greek letter, okay? It's a Greek letter, and it means, it's called sigma, but what it means the sum. So it's like, what if I took every element in the set, all the numbers in the set, and I added them all up together? I would get the sum, right? Another word for sum, sometimes we say total. Total from addition, if we're adding up, okay? So that's another one that we get there. And I'm not going to get into all of them, but I'm going to show you another couple more that you'll see in this. There's other symbols that you're going to see, and we're not going to get into all of them here for your notes, but there's one that has N with an underline, and that we're going to say is your count, meaning it tells you how many items are in your list, or how many elements are in your list, okay? And then you have min x, q1x, median x, q3x, and max x, which we've already gone over, okay? But these I wanted you to remember separately. So again, min, max, q1, q3, you can get it all right there if you had to find that on a test. And trust me, I think you're going to have to find that on a test. Okay? All right, we're going to continue to make notes here. Okay? And we're going to now say, what if I wanted to graph something, right? What if I wanted to graph? So to make a dot plot, so what would I do now? Okay, so if I want to make a dot plot, I need to add in a page. So let me get back my list going here again. So we want to add a data and statistics page, right? Data and statistics page. So how do we do that, right? So to do that, we are going to do control doc, right? And then what we do, and then we're going to add in data and statistics, right? So make sure you do that. You say control doc, and then add data and statistics, which is what, 5, I think. Okay. Then on the x-axis, select the name of your list. So I'm going to come down here, I'm going to click on that axis, and I'm going to select the name of my list, and that gives me a dot plot. And then let's take that number off and get another little title here, which I'll go back here and say to make a box and whisker plot. Okay. So now that I've got my dot plot, I want to be able to make a box and whisker plot. So to make a box and whisker plot, I'm going to go menu, and then I'm going to let me get typing here. Sorry, menu, and then plot, menu, comma, plot type. Okay, and then you would say box plot. Okay. Now, why do we want the box plot, right? Well, I'll draw that out for you real quick. You might make a little sketch here to the side. See if you can see my little sketch here real quick. What's nice about a box plot, right, is it kind of shows you how the numbers are graphed and grouped together. So you end up with, you know, over here, this would be your min, right? That's your min. Okay. And over here, this is your max, right? M-A-X. And then you have your median right here. That's where your median is right here. And this is Q1. And here we have Q3. And sometimes it's really good to see that, because if you have a huge long whisker all the way down here, well, then you have something that we call an outlier, which we need to go over and add to our definitions. We need to get into the outliers. But it tells you how closely grouped together things are. If the lines are real close together, that means there's a whole bunch of data close together, right? And if it's really spread out, then you know, the data is not really close together. It's, you know, really spread out. But if you have a whole bunch of data close together, then the box gets really small and the whiskers get really stubby. And that's a sign that your data is all very closely grouped together. But once in a while, you'll have all your data really closely grouped together and one way out there, and then that's how you get an outlier. So let me go ahead and let's add that into our list over here. So let me take this off. And let's go over to here. This is another one of our definitions we need to add in, right? And that definition is for an outlier. Any element in the set that is significantly farther away from all the other elements in the set. Okay? And again, when you get to Algebra 1 in high school, we will practice learning how to formally identify outliers, because there is a formula for that. Okay? You have to learn about interquartile range, which is the 50% that is closest together in the center. And then we learn about setting an upper and lower fence based on how close together half the group is. We can set a fence from there, and anything that goes out past the fence is what we call an outlier. But we're not doing that in this class. We just want to make sure we understand about outliers. Now, outliers, let me just tell you a story. I was looking the other day at houses, okay? And I'd gotten an email. They said, hey, you should look at this house that we want you to buy. And I was really interested, so I looked, and this was a $8 million house, okay? So something I'm not going to be able to buy. You'd have to comfortably live in that house, you'd have to have way more than $8 million, because the property taxes and the utilities and the cost to maintain and keep it up and everything else, somebody would have to have at least maybe $50 million or more probably to live in that house, my guess. But anyway, it's more money than I have. So anyway, but I looked at it. Now, most of the houses that I look at, they're not anywhere like that. They're much closer to the price of my own house that I have right now. That house then is an outlier for me. It is a house that is so far out there in price that it is not even close to what I would ever spend on a house, or that I can imagine spending on a house. So it is an outlier. And if I include it when I talk about homes that I'm interested in, then it would throw things like the mean or the average way, way, way off. So, we have to think about, if we can identify that there is an outlier, we think about, can we maybe exclude the outlier so that we get a better idea for what the rest of the data is like. And that's always a pretty good idea. Okay, so that's how we would do our outlier. Okay, let's go back to our calculator now to talk about some other things we want to do. What if you have two quantities, right? So we didn't do a single stat calculation, but we are wanting to check for correlation between two quantities. So we'll take this guy off here, and let's go up here to checking for correlation. So then we're on our data and statistics page, right? And we would go back to the dot plot. So I guess we may put a note in there. Oops, I forgot to change everything back. Let's see if I can do this. Okay. And change the font back to a small font. Okay, so go back to dot plot. And to do that, you would go menu, plot type, and box plot. So now we go back to the dot plot. We would add a second list or quantity, whatever we've measured there, to the y-axis, right? And then you'll see the dots all kind of get lined up, and then that is what we call a scatter plot. Okay, when the dots are moved around, then we'll end up with a scatter plot. So that's how we would do that. And then we can add a line of best fit. So to add a line of best fit, okay, what we're going to do is we're going to go menu. All right, hold on. Let me double check this. Yeah, get caught up here. So menu, analyze. And regression, and then show mx plus b. And what that'll do is it will add in a line of best fit and give us the pattern. And we've studied patterns before, right? mx plus b. M tells us how the pattern is moving, and the b tells us where the pattern begins. So it's kind of like moves up or down, right? So it's like we're saying here, moves up, if this is a positive number, we'd say up, 21 each time. Remember the X is each time. Let me make that a lowercase x, right? And B is where it begins. So it would give us a line and say, hey, this pattern looks like it begins at this number and it goes up this each time, or goes down this each time. That's how we read and interpret that once they show us that line. And then we can make a prediction. Hey, is it on the line? And we start checking about how close things are to the predictions. Keep in mind what we talked about with the animals the other day, and the size, their weight and the size of their brains, and how certain animals, like the donkey, had the reputation for being not a very good animal, not very intelligent, but that their brain size was maybe larger than might be expected for their weight compared to, say, the horse. The horse, which we think of as a smart animal, but its brain size was still a little bigger than the line of best fit predicted, but it wasn't as much bigger as the donkeys. The donkeys was significantly bigger. And then we saw that correlation that as animals got heavier, their brain size got bigger, right? That was a positive correlation. And then we noted where were the exceptions. So don't forget that the humans, we were a significant exception. Based on our weight, you wouldn't expect the brain size to be so big, but it was enormous, right? And when you start looking at other animals, some of the other ones that were significantly smarter, like the rhesus monkey and the chimpanzee, those guys were pretty smart relative to their weight. So anyway, we check for correlation, we add in the line of best fit, and then we compare where is the data compared to that line. And we can look and see the line is the prediction. The line helps us predict and see that correlation a little better. And it also helps us analyze if the dots are really close to the line, then we have a strong correlation, and if the dots are far off the line, we have weak correlation. And sometimes we might just say we have no correlation. There is no correlation at all. Okay, so now we know how to get all of the things that we needed plotted and get it graphed and everything else. We know how to find and interpret and understand what is the mean, the median, the mode. Look for outliers, look for correlation. We understand the idea of hemispheres, left and right, and all of that. So that is a good amount of notes for us to start here. That would help us with a lot of these kinds of problems. So what we're going to do is I'm going to just stop for just a second, and I'm going to get a couple of problems loaded up here in our video, so hang tight. Okay, so here we have, let's see if I can make this a little bit bigger here. Okay, it says here is the data on the number of cases of whooping cough. Whooping cough is a disease, an illness. So between the years 1939 and 1955. So here we have the years. They're not in order. I can see 1939 is here. And so the years are not in order. And the number of cases are not in order either. But you can see it's all laid out there. So here's your first thing I want you to do. Is you want to make a new table that orders the data by year. Okay? So you would put them in order by year in that table. And then answer the question, which years in this period of time had fewer than 100,000 cases of whooping cough? Okay? And then, based on this data, would you expect 1956 to have closer to 50,000 cases or closer to 100,000 cases? Okay? So make sure you're putting in this data. 1941, 222,202. That's the number of cases in 1941. In 1950, 120,718. Right? 120,718. 1945, 133,792. 1942, 191,383. 1953, 37,129. Now, if I'm going too fast, you pause the video and rewind, okay? But you got to get all this put in, so I'm going to keep moving. 1939, 103,188. 1951, 68,687. 1948, 74,715. 1955, 62,786. 1952, 45,030. 1940, 183,866. 1954, 60,866. 1944, 109,873. 1946, 109,860. 1943, 191,890. 1949, 69,479. 69479, that is 1949. And then 1947, 156,517. Okay. All right. I wouldn't worry about making a new table, actually. Now that I think about it, you could probably skip that part there. But I would definitely make a data and statistics page. I would put the years on the x-axis and the number of cases on the y-axis. And notice you got to decide when you name the list what to name it. Here it says year, so that should go on the x-axis. And then over here it says number of cases. Cases is a good way to summarize that, right? Just cases, and put that on the y-axis. Now, normally we like putting time on the x-axis. So usually whenever you have something that goes by year, it's a good idea to put it over here on the x-axis. Years, days, months, whatever. Okay? Anything that's time related. Now, after you've done that, you can see if there's a correlation, and then you can make a prediction. What do you think about 1956? Would it have closer to 50,000 or closer to 100,000? So now here they're showing you it's all put in order, and you can see that it would suggest that it's going down over time. It's pretty 100, 180, 222, 191, 191, 109, 133, 109, 156. But look, in the last decade here, it only got over 100,000 one time, right? And then it was low, below 100,000, and now 68, 45, 37, 60, and 62,000. That's below. That's closer to 50,000. So the data seems to show the number of cases decreasing over time. So I would expect 1956 to have closer to 50,000 cases than 100,000 cases. Okay? So now we get a chance to see a scatter plot problem 2. Here we have the number of blocks and the blocks per game listed, right? Blocks and blocks per game. Okay? And now you can see, what would this be that we're listing over here? This would be the total number of blocks, and this would be the blocks per game. Blocks per game. So you can see that if we listed that data out, there does appear to be what? Some kind of correlation. Right? If you have had more blocks, you probably got more per game, right? Okay. So that's saying the horizontal axis should be labeled the blocks, right? That these are the blocks, and the vertical should be blocks per game. Now, you know that they're going to take them from here. Here's another little clue on that too. Usually the first column is the X column. X comes before Y, right? So, and this is the first number line you learn, so usually the first list goes down here. The second list goes up there. That's usually how they like to do it. Alright. Alright, so it says, this is a practice problem from a different lesson. I'm going to skip that, okay? Alright, next one. Here you have assists and points, and you have a scatter plot, and now you can see that there is a line of best fit created, okay, in the scatter plot. Alright, and we're going to skip those problems for a minute. Let's go ahead and take a look at another type of a problem that you could see. Here is a table and a scatter plot that compares points per game to free throw attempts for a basketball team during a tournament. So player A took 5.5 free throw attempts in a game and averaged 28.3 points in a game. Okay? And then that continues here for B, C, D, E, and F. And it just continues. There's the scatter plot. Okay? And it says circle the point that represents the data for player E. Well, player E was 3.1 free throws, 10.4 points. I'm going to come here. 3.1 would be right about here. And there's 10.4 right about there. So that one I would circle as player E. Okay? All right. And let's see. We're going to skip that. Here we have another scatter plot. Okay? You can see the scatter plot. All the line of best fit is in there. We have a positive correlation. Okay? Here's another one. The number of free throw attempts per game and the points per game, and we have our correlation or our line of best fit. Now, when you do the line of best fit, and remember how to do that in your notes, you've written that we're going to go in there and we're going to do a regression. So we analyze the data, and then we do a regression, and we do show mx plus b. So this is telling me that, this pattern kind of begins at 0.377, and then it goes up 4.413 for each free throw attempt per game. So the total number of points that you score on average goes up about 4.4 points for each free throw attempt you attempt. And that makes sense. The more likely you are to take free throws is because you're getting fouled. That's usually why you take free throws. And you would take more of them if you're playing more minutes, and you play more minutes if you are a better player. So it would make sense that the people making the most free throw attempts per game are also the people scoring the most points per game. So there should be a correlation there. All right, what do we think? This is what kind of a correlation here? This is a negative correlation. It's pretty strong too. Okay, and there you see it. Pretty strong negative correlation. How about here? What do we have here? I could see a line right here. Somebody might draw a line right there. But man, that doesn't really show. I don't know that you do have. I don't know how you sit there and say for sure that we have, any kind of positive correlation for sure. Okay. And I think probably I wanted to skip down here a little bit. You can see there's a ton of different ways this gets done. You have this beautiful butterfly, and you can measure each butterfly's wingspan compared to its body length, and you'll find there's a correlation there too. The larger the wingspan, usually the longer the butterfly, right? That makes sense. Let's see. Here we have groups. This is always interesting. Okay. Literacy rate and population for countries with more than 100 million people. So as the population goes up, you can see, we just have a divergent group over here. So you have this group up here that is together in a cluster, and this group down here that's together in a cluster. And then later on, even with this many more people, you have, some divergence there as well. But there's the clusters that you see. There's a scatter plot. And how would we describe the scatter plot? I think it looks pretty much like a straight line, so we would call that a linear association. We would also select positive association, because it looks like it goes in a straight line, and it is positive. As age goes up, the weight goes up as well. Okay. And I think, let's see if we've got a negative correlation. I'm just going to double check. This is an interesting one, isn't it? Where the weight goes up for a long time, but then it kind of stables out. And that's kind of, becomes very stable pretty quick. Okay. And here we have initially a very strong correlation, but over time it gets weaker and weaker and weaker, the correlation. as a negative correlation we just looked at. All right, we start getting into looking at tables and graphs a little bit differently. Now we have, this is called a bar graph. We're tracking blue water and green water and seeing how much water intake there was from cats and dogs. So it looked like that for dogs, they drank a little more water when it was blue, right, than when it was green. And for cats, it looked kind of the same. Okay. All right, here we have another example of a table to be read. You can see that they're taking the total amount of reading that somebody does and saying how much of that is stuff they read that was printed on paper and how much of that was stuff they read that was on the internet. And it's interesting because you see something else happening here. What's happening here? The older somebody gets, not that they're reading less, but the type of stuff that they're reading, you can see it is less likely they're reading on the internet. They're more likely to be reading print media as they get older. Okay? So there's some examples of problems that we might see and be asked to kind of interpret. And with that, I'm going to call it an end to this video.